for solving rational inequalities. Okay, so it's the same process except now you have an inequality, so you have one extra step. Okay, one extra step here. So we are solving rational inequalities. Those are inequalities that contain one or more rational expressions, and you have to follow the steps below to solve them. Okay, so step one is to state the excluded values. Since it is a rational inequality, your denominator cannot equal 0. So you have to see where your denominators are equal to 0 so you can exclude that value. Okay, so values for which the denominator is 0. It's the first thing you need to check. Step 2 is to solve the related equation. So that's what we were doing on the front. Okay, find the least common denominator, multiply it through to find your variable. Step 3 is to use the values determined from the previous steps to divide a number line into intervals. And then step 4 is to test values in those intervals. Okay, so we're going to do this in example 3. We have 4 over 3x plus 7 over x is less than 5/9. Okay, so step 1. Step 1. You're seeing where your denominators are equal to 0. Okay, so you want to set your denominator of 3x equal to 0 and solve for x. Okay, so I would divide by 3. I still end up with 0. Okay, same thing in your other denominator. Okay, I just have x is 0. Okay, it's the same thing. So x cannot equal 0 in both of those cases. So that was step 1. Step 2 is to solve our equation. Okay, in order to solve our equation, we have to find out what the least common denominator is. Okay, so I need to take each of my values here and factor them. So I have 3x. Okay, that just factors into 3 times x. I have x, which is just x. And I have 9, and that factors into 3 times 3. Okay, so we're finding that least common denominator. So we need to take our first term, which is 3 times x, move to our second term. I already had an x, so I don't need another one, right? Move to our third term. I had 1 3, but I need one more 3. So I'd multiply by 3.
Wait, so how did you get 3?
Where?
Right there.
Right here?
No, there's a 2.
Right here?
No, the other one? No. Up. One more, there you go.
This one?
Yes, ma'am.
I took the denominator.
Why?
You're taking each of the denominators to find your least common denominator. 3x, x, and 9. You're trying to find your least common denominator. So here your least common denominator is 9x. So that's what you need to multiply each of your fractions by. Okay, so within step 2 here, I would have 4 over 3x. Okay, multiply by your least common denominator, so 9x. Okay, plus our second fraction is 7 over x. Multiply that by your least common denominator, which is 9x. Okay, that's less than 5/9. And again, you have to multiply that one by your least common denominator, which is 9x. Okay, so I'm just bringing this least common denominator I found up here. So from here, this is where we could cancel things out, because I want all three of my denominators to cancel out. So I have 9 over 3. Okay, that cancels to a 3. And I have x over x. Those two just cancel each other out. Second fraction here, I have x over x, so those cancel. Last one, I have 9 over 9, so those cancel. So your denominators should always cancel out in these problems. Okay, next I can rewrite. So I have 4 times 3. Shh. Hey, pay attention.
I can't.
Then leave. 4 times 3. Go to the office then.
Oh, no.
Okay, then stop.
I don't trust them.
4 times 3. Then I have plus 7 times 9 is less than 5 times x. Keep your comments to yourself. You can watch the video on Canvas because it was posted yesterday when you were gone. Okay, so here I have 4 times 3 is 12, plus 7 times 9 is 63, is less than 5x. Okay, I can add 12 and 63 to get 75. And then to get x by itself, we would divide both sides by 5. Okay, so right now I have 15 is less than x. I'm going to flip that so that it reads x is greater than 15. Okay, so I just read it backwards. So x greater than 15, just so it's easier to look at. Okay, our next step, so step 3 is to create a number line with our restrictions here, with our intervals. Okay, so step 3. Here's the number line. Now, your intervals have to do with step 1 and step 2. So in step 1, we said x cannot equal 0. So that has to go on your number line. Okay, so 0 has to go on your number line because that's what x could not equal. Okay, my other number that I found in step 2 was 15. So that one has to go on your number line as well. Okay, then step 4 is to test values between each of those intervals. So I have to test a value to the left of 0, between 0 and 15, and above 15. So I have to test 3 different values in step 4. Okay, so for less than 0, I'm just going to plug in x is negative 1. Okay, that's less than 0. So if x is negative 1, I need to plug that into my original, which is up here. So plugging in negative 1 for those x values in the original problem. We would have 4 over 3 times negative 1 plus 7 over negative 1 is less than 5/9. Okay, so here I would have 4 over negative 3 plus 7 over negative 1. Now if I add these two fractions together, it's going to result in a negative, right? Yes? If I add those two fractions together, it results in a negative. Is a negative value less than 5/9?
Yes.
Yes. So this works. Okay, so I tested -1, that was on the left of 0. So I know I can plug in values that are less than 0 for this to work.
You already grabbed
You have to put it on a number line. Okay, next I need to test a value between 0 and 15. What value should I pick?
it. 6.
What's the easiest value to pick between 0 and 15?
51.
1.
We could do 6 though, right?
Yes, you could.
11.
Okay. So plugging in 1 for x, I would have 4 over 3 times 1 plus 7 over 1 is less than 5/9. Okay, I'm going to change each of these denominators to 9 because that is your least common denominator. So to get 3 to 9, I need to multiply numerator and denominator by 3. So 4 times 3 is 12. 3 times 3 is 9. Okay, 7 times 9 is 63. 1 times 9 is 9. Less than 5/9. When I add these together, is this less than 5/9?
No.
It is not less than 5/9.
So you're wrong.
So that one does not work. So my values between 0 and 15 do not work when I plug them in. Okay, the last one I need to test is greater than 15. Right?
No.
Okay, so any number greater than 15. What number should we use?
40 over 15. Use 100.
Don't use 15. You can use 16. Okay, so we have 4 over 3 times 16 plus 7 over 16 is less than 5/9. Okay, and I'll let you enter it in a calculator if you have one. Okay, so if you have a calculator, you want to enter this. First, I need to know 3 times 16. Okay, that's 48. So if I take 4 divided by 48, okay, and add on 7 divided by 16, okay, I get about 0.521, right? Oh, it wasn't on there. Do you see how I did that in your calculator, though? Yeah? Okay, and then I would check what 5/9 is. 0.56. There's no 4 there. Okay, so is this value less than this value? Yes. So those values work to the right. Okay, so then my final answer, I need to write it as my x values are less than 0. Okay, so x is less than 0 or x is greater than 15. Okay, because I have that between here. Okay, x is less than 0 or x is greater than 15. Okay, so I just tested each of those points on that interval. Questions?